Hi friends, see today I'll be starting in second year physics, that is sound waves. Okay, so I'll be starting sound waves chapter, very important. Sound waves. In this, around 2 to 3 marks will be coming from MSET. In this chapter, you will be getting around 2 to 3 marks. Now let us know what is meant by sound first of all. Sound ante enti? Okay, see, just like energy, sound is a form of energy. Sound is a form of energy. Sound is a form of energy. Now, to travel sound, what are a requirement for the what are the main things requirement to travel sound? Sound travel అవ్వాలంటే మనకు కావాల్సినవి ఏంటి? See, first of all, you should have a medium, because without a medium it cannot travel. Are you following the point here? Sound requires a medium, because like solid, liquid or gases. And not only that, because solids are tightly packed with atoms, liquids and gases are loosely packed, the sound is more in solids than in liquids than in gases, or gases less than liquids less than solids. Sound means velocity of sound is more in solids than in liquids, least in gases. So to travel sound, what is required? A medium is required, material medium. So in vacuum, sound cannot travel. In vacuum, okay, sound, because there is no air molecules, no medium, whereas light can travel even through vacuum, because it is an electromagnetic wave. It is an electromagnetic wave. So sound travel అవ్వాలంటే మనకు ఒక మీడియం కావాలి. Either solid, liquid or gases. So the best thing experiment in the laboratory is a tuning fork. In physics lab, you may be seen this tuning fork. When you excite the tuning fork, a booming sound is heard. Okay, a booming sound is heard. For example, this is a tuning fork. It is excited with a rubber hammer. Then what happens? This booming sound is transferred in this fashion, and you know these two are called as prongs, and this is called as stem. These two are called as prongs. Down portion is called as stem. So when it is excited with a rubber hammer, the prongs, what happens? They will be, due to elastic nature, it will be compressing and leaving. When it is compressing, the air molecules are compressed. Okay, and due to elasticity, again it is relieved. So therefore, what happens here? In air, these are compressed. Molecules are air molecule compressed. Again, due to elasticity, it is relieved. Again, it is compressed. Again, it is compressed. Again, it is relieved. Compressed. And again, it is relieved. So, what happens? It travels in the form of compressions and rarefactions. Compressions and rarefactions. That's the point. So before it is coming to the eardrum, ear of the human being, it is traveling in the form of what? Compressions and rarefactions. Okay, and distance between any two consecutive compressions or distance between any two consecutive rarefactions is equal to wavelength lambda. Clear? So distance between any two consecutive compressions, please, or air fractions is equal to wavelength lambda. So in this way it is reaching the eardrum. So this is how the experiment is done for production of sound in the laboratory. Okay, right. Now let us go still further. As I said just now, sound waves are what? Longitudinal progressive waves. Sound waves enti? Longitudinal. It is not transverse, because transverse means what happens? It forms crest and trough. These are longitudinal because these are parallel to the propagation of the wave. So sound waves are longitudinal progressive waves. Longitudinal progressive wave. So sound waves enti longitudinal, that means displacement. Just now you have seen displacement are parallel to the propagation. Displacement are parallel to the propagation. That is called as, అందుకే ఇది ఏంటి, it travels in the form of compressions, rarefactions. Compressions, rarefactions. Okay, so it is traveling in the same direction of the displacement of the particles. Particle displacement ఎలా ఉంటుందో అదే విధంగా వెళ్తుంది. That is why it is longitudinal progressive wave. Now you know what is meant by progressive wave. Progressive wave అంటే ఏంటి? So any wave which starts from the media travels to infinity. Travels to infinity media. That is called progressive wave. And suppose if you put any obstruction, it may come back again. Suppose a medium which is created, a wave which is created in the medium, what happens? A progressive wave is formed. ఎలా ఉంటుంది a wave చూడండి. It goes in this form. It goes to infinity medium. But suppose if you put any obstruction, again it may come back. Again it may come back. Okay? We have an experiment also in the physics laboratory for formation of stationary waves or standing waves. Okay? So a wave which is formed in the medium, suppose if it is traveling to infinity medium without returning back, unless and until if any obstruction is kept, that wave is called as a progressive wave. And if you put any obstruction, it will come back, and thereby a standing or stationary wave is formed. Later on we'll be studying about that one. Okay, right. Now regarding these sound waves, we have to learn some more things. Okay, regarding these sound waves, we have to learn some more things. That is progressive wave equation. Progressive wave equation. See, these are very, very important. Please try to understand how to write the equation. Okay, so generally what happens is progressive wave equation is written as either y is equal to a sin kx minus omega t, or you can even change this one, y is equal to a sin omega t minus kx. Anyway it is right. Either you can write in this or in that. But here one thing you have to make in mind. What is y here? Is there y is nothing but displacement of the particle. What is y here? Displacement of the particle. Okay? Y, displacement of the particle. And what is x? In x direction. X and ikkada x direction. The wave is in x direction. Positive x direction, please. The wave is going in positive x direction. చూడండి ఒకసారి I am drawing the graph. Suppose this is x direction, positive x. Okay? So wave is going in this fashion. So this is the displacement, you can see. This is the displacement of the particle. So it in which direction? It is y direction. So the particle is going in y direction. Wave is in x direction. Wave is in x direction. When these type of functions are coming, equation, this x indicates x direction wave. Suppose if here y is coming, then the wave is in y direction. If z is coming, the wave will be in z direction. Okay? And here y means displacement of the particle, please. You can see here. Particle displacement. Okay? Not wave, please. Particle displacement. And wave direction is along positive x. ఇక్కడ ఒక విషయం గుర్తుపెట్టుకోవాలి మీరు. Regarding equation, y is equal to a sin kx minus omega t. If here you can see this k is constant, or it is also called as wave number or progressive constant, progressive wave constant. This k is also called as wave number or progressive wave constant. Its value is nothing but 2 pi by lambda. 2 pi by lambda. Wave number కాబట్టి దీని యూనిట్స్ ఏమవుతుంది చూడండి, 2 pi constant 1 by lambda. Lambda is nothing but wavelength. So its units are meter inverse or centimeter centimeter inverse. Easiest unit centimeter inverse. M case is meter because 1 by lambda. Lambda is wavelength kada. 1 by length. L power minus 1. So when both are plus, one is plus and another is minus. Wave number. And x is the wave propagation in positive direction. And omega, angular frequency please. What is omega? Angular frequency, which is given by 2 pi by t or 2 pi n, where n is frequency, t is time period, and t is time. T is a time. Okay? And A is amplitude. A and amplitude. That means the maximum displacement of the particle from the main position during the oscillation or vibration. And Y is the displacement of the particle. A is amplitude. So ఇక్కడ గుర్తుపెట్టుకోవాల్సిన విషయం ఏంటి ఎగ్జామినేషన్లో ఎంసెట్లో కానీ నీట్లో కానీ సపోజ్ వన్ ఈజ్ ప్లస్ అనదర్ ఈజ్ మైనస్ ఇట్ ఈస్ ఇన్ పాజిటివ్ డైరెక్షన్ ఆఫ్ ఎక్స్ బికాజ్ ఎక్స్ ఈజ్ ఫంక్షన్ హియర్. Suppose here y is given y direction, z is given z direction. In the same way, if both are also minus, అర్థమవుతుంది ఇక్కడ ఏముంది ఇక్కడ సైన్ ఇక్కడ ఒకటి ప్లస్ ఒకటి మైనస్ ఉంది, ఒకటి ప్లస్ మైనస్. అలాగే సపోజ్ బోత్ ఆర్ మైనస్, మైనస్ కేఎక్స్ మైనస్ ఒమేగా టీ, దెన్ ఆల్సో వాట్ హ్యాపెన్స్, నెగిటివ్ ఎక్స్ డైరెక్షన్, negative x direction. See here one thing very clear, if one is plus another is minus, positive x direction depending upon the function given here. X అయితే x direction, y అయితే y direction, z అయితే positive z direction. అలాగే రెండు ప్లస్లు అయితే ఫర్ ఎగ్జాంపుల్ చూడండి, సపోజ్ ఇఫ్ యూ రీడ్ like this sin of either omega t or kx like this. See here, if both are plus or both are minus, both are plus both are minus, it is in negative x direction of the function. X అయితే negative x, y అయితే negative y, z అయితే negative z direction. So these are how you have to express the progressive wave equation. Very very important regarding the examination point of view. Please write down. Now let us discuss some more points regarding, that is, how these equations will be changing as and when according to the requirements. So మన రిక్వైర్మెంట్స్ ప్రకారంగా ఈ ఈక్వేషన్స్ ఎలా మార్చుకోవచ్చు, ప్రోగ్రెసివ్ ఈక్వేషన్స్. Let us write all those equations. Okay, let us write all those progressive equations. Okay, now I am writing here, see, displacement of the particle is equal to a sin kx minus omega t. Anyway you can write, I told you just now, omega t minus kx and రాయొచ్చు, kx minus omega t. Okay, nothing problem here. And what is this one, you know, what is this kx minus omega t? Can anybody tell what is this kx minus omega t? Okay, and this is called as, of course, phase in generally. Kx minus omega t is also called as phase. Okay na? Sometimes it is also given like this also, kx minus omega t plus something, some phi. Okay, some phi is given. Okay, sometimes it is given as some phi, minus phi or plus phi. Then this entire thing is called as phase. This entire thing is called as phase. That means the position of the particle. Okay na? You got the point ikkada? Kx minus omega t plus phi లేదా minus phi ఇచ్చినప్పుడు, then this entire thing is called as phase. Okay, that means what is the position of the particle. And if there any difference is there between the first wave and second wave, then that is called as phase difference, and it is given by d phi or delta phi. Delta phi is called as phase difference. If any difference is there between two waves, okay, and please make a note, the wave can be written in sine wave or cosine function, but while doing numericals you have to convert into sine function only. If cos is given, you can change into sine. I will tell you how to change the function also. Okay, so this is the general equation. It is, this wave is going in positive x direction. I told you just now, if one is plus another is minus, both are plus both are minus, negative direction of the function. X is the x direction, y is the y direction, z is the z direction. So here if in such cases kx minus omega t plus phi minus phi ఇచ్చినప్పుడు that entire thing is called as phase. ఓకేనా? ఆ మొత్తం భాగం అంతని phase అంటారు. Clear? Right. Now let us see some more terms. Just now I told you wave velocity. What is wave velocity? We all know wave velocity given by v into n lambda. N is frequency, lambda is wavelength. Some people in authors books they are writing n is equal to f. This is also right. You can either adopt frequency f and రాయొచ్చు లేదా frequency n అని రాయొచ్చు. But I will write n only, standard form frequency. So the equation for standard equation for wave velocity is v is equal to n lambda. You can write another form also wave velocity. Elaga wave velocity is also given by, see here, another important one, coefficient of t by coefficient of x. I can also write wave velocity in another form. Coefficient of t by coefficient of x alaga chudandi. V, what is coefficient of v? Coefficient of t omega and alaga coefficient of x k. This is also another form of writing wave velocity. Omega by k. You can prove also this one. Chudandi. What is omega? 2 pi by t by what is k? Just now I told you k is wave number 2 pi by lambda. So 2 pi by lambda, that is equal to 2 pi by t into lambda by 2 pi. 2 pi gets cancelled. What is left over? Lambda by t. Lambda by t and enti lambda 1 by t means n lambda. Proved? So therefore v is equal to n into lambda. So wave velocity equation you can write as coefficient of t by coefficient of x, or simply v is equal to n lambda. Clear? Right. Now let us go to the next one, particle velocity. Okay, wave velocity అయిపోయింది. Particle velocity ఎలా ఇస్తాం equation. Please write down. Next equation, particle velocity. So wave velocity మనకు తెలిసిపోయింది. Coefficient of t by coefficient of x. This is wave velocity. That is omega by k. Now particle velocity la kadam. Particle velocity. See, particle velocity is very simple and v is equal to a omega. Just like v is equal to r omega ela rastunnaro, a omega. A is amplitude, omega is angular frequency. This is another equation. These two are very very important while solving numericals. Okay na? This is wave velocity, v is equal to omega by k or n lambda, or particle velocity just like r omega. Okay, here a is amplitude, omega is angular frequency. And what is the relation between these two? You can also find some relation also. Okay, relation between vp and particle velocity and wave velocity. You can also find the ratio also if you want. If you're required, you can find the ratio. Okay? See here. Particle velocity by wave velocity is equal to a omega by, what is this one? V. That is omega by k. Omega by k. So I can write as a omega by omega k pi k వెళ్ళిపోతుంది. Omega cancel. A into k, or a into what is k? Wave number 2 pi by lambda. So finally ఏంటి వచ్చింది మనకి? Particle velocity by wave velocity is given by ఏంటిది? A by lambda into 2 pi, or 2 pi a by lambda. Okay na? So you can use this formula while doing numerical problems. Very very easy. Okay, please note down. We will go to the next one now. Clear? Okay, now I will write the equations of progressive wave in different way as and when required for the examination. ఇదే ఈక్వేషన్ ని రకరకాలుగా మనం ఎలా రాయొచ్చు. ఫర్ ఎగ్జాంపుల్, see here, displacement of the particle y is equal to a sin kx minus omega t. This standard form అని చెప్పాను. Going in positive direction because one is plus, another is minus. Both are plus, both are minus. It will go in opposite direction of the function x here. So ఇక్కడ మీరు చూసే ఉంటారు ఈ ఈక్వేషన్ని యూ కెన్ రైట్ ఇన్ డిఫరెంట్ వే. ఎలాగా ఏ సైన్ చూడండి ఒకసారి వాట్ ఈస్ కే. సిన్స్ కే ఈజ్ 2 pi by lambda, I can write it as 2 pi by lambda x minus what is omega? Omega is 2 pi by t, that is 2 pi by t into small t. Now yp is equal to, that is displacement of particle, a sin, take 2 pi outside, inside x by lambda minus small t by t, capital T. This is one type of expression. Now you can still change this equation. Displacement of the particle is equal to a sin multiply and divide with lambda. Multiply and divide with lambda. Multiply and divide with lambda. Numerator అప్పుడు ఏమవుతుంది, lambda 1 will be in the denominator, 1 will be going inside. అప్పుడు ఇక్కడ ఏమవుతుంది, lambda x by lambda minus lambda small t by capital T. Or this equation goes like this, a sin 2 pi by lambda, this will be cancelled. Inside what is there, x. Okay, so here you can observe here what is this k value. I told you k is 2 pi by lambda, 2 pi by lambda. సో అందుకే ఇక్కడ ఏం చేశారు, మనం 2 pi కామన్ తీస్తే లోపల x by lambda మైనస్ స్మాల్ t by t. ఇక్కడ ఏం చేశాను, మళ్ళీ నెక్స్ట్ ఈక్వేషన్లో మల్టిప్లై అండ్ డివైడ్ బై lambda చేశాను. బికాస్ మల్టిప్లై చేసినప్పుడు లోపలికి వెళ్ళిపోతుంది, ఇది లోపలికి వెళ్ళిన తర్వాత ఏమవుతుంది, ఇది క్యాన్సిల్ అవుతుంది. ఓకే, సో ఓన్లీ x is left over minus. Here what will be there, lambda small t by capital T. Now you can see this one, displacement of the particle is given by a sin 2 pi by lambda into x by what is 1 by t frequency. So lambda n t. So what is n lambda? Again v. So this equation again changes as in this fashion. Displacement of the particle is given by a sin 2 pi by lambda into x minus vt. So these are some expressions for progressive wave equations in different forms. So these you have to use in the numericals while solving typical problems. Okay, right. Now let us see a small example to understand in a better manner. Okay na? Shall I rub this one? Right, here now in the sound chapter, it's a very big chapter, of course, it's not an easy one, big chapter, lot of concept and numericals are also there. Let us give a small example. చిన్న ఎగ్జాంపుల్ తీసుకుందాం. యాజ్ ఐ టోల్డ్ యూ, డిస్ప్లేస్మెంట్ ఆఫ్ ద పార్టికల్ ఈక్వేషన్ ఏమి ఇచ్చాను, ఏ సైన్ కేఎక్స్ మైనస్ ఒమేగా టీ లేదా ఒమేగా టీ మైనస్ కేఎక్స్ అలా రాయొచ్చు. I'll give some example, standard value. Displacement is given by, for example, 0.4 sin 2 pi. Okay, what is that value? Pi by 3x minus, I'll change this one otherwise. I'll change this one. Because as I told you, you can write in different form, either kx minus omega t or omega t minus kx. So here 2 pi t minus pi by 3x. Just చూడండి ఒకసారి. I have given some numerical here for you. So in this, how to compare these two? You can compare. What is A? If these are in SI units, what is A? A is nothing but 0.4 meters amplitude. Now what is omega angular frequency? In the place of omega, what is there? 2 pi. But what is omega? 2 pi by t is equal to 2 pi. 2 pi gets cancelled, so t is equal to 1. So what is 1 here? Time period, second, 1 second. Now we got time period, amplitude. Wave number also you can find out. See here, wave number k. So in the place of k, what is there? Pi by 3. Pi by 3. What is k? 2 pi by lambda is equal to pi by 3. Pi cancel. 3 2s are 6. Therefore, lambda is equal to 6. What is lambda? Wave number. What is lambda? Wavelength, in other words. Okay, na? So 6 meters, SI units covered. Wavelength. So like this you can calculate the values. If any problem is given, depending upon the requirements, you have to change the formula. Either you can write kx minus omega t or omega t minus kx. Please note down. Clear? Okay. Now, let us go still further in this chapter, sound waves. Now, as I said in the before, regarding phase and phase difference. In the mundu kuda cheppanu just beginning lo, phase difference. Okay? Let us still discuss some more things regarding phase and phase difference. For example, take an equation displacement y is equal to a sine omega t plus kx plus phi. I told you when both are plus, it is a negative x direction. Function is x here. Suppose like this it is given in the examination. That is a sine omega t plus kx plus phi. Then this entire part is called as phase, please. This entire part is called as phase. The position of the particle or the position of the wave or first wave or whatever second wave given. Okay, na? So that is called as phase. This entire part is called as phase. That means it is differing. It is either it is going leading or it is lagging. If I anything, either it may be leading by first wave or lagging by second wave. That's the point. Now I will express in different forms for the phase difference. Let a wave, first wave be y1. Okay, y1, a1, that is first amplitude, into sine k1x plus omega 1t, or second wave also you can take like this, a2 into sine k2x plus omega 2t. So here I have taken two waves. One is a1 sine k1x plus omega 1t, y2 another wave, a2 sine k2x plus omega 2t. Okay. Now here you observe carefully. This is phi 1. This is phi 2. This is first phase of the first wave and this is second phase of the second wave. Now how you will express the phase difference? Phase difference in the delta phi. Phase difference is equal to, for example, this is higher than this is lower. Phi 2 greater anukundo. Let us assume that phi 2 is greater than phi 1. Then phi 2 minus phi 1 is called as phase difference between these two waves. Phi 2 minus phi 1 ni మనం ఈ రెండింటి యొక్క phase difference అంటాం. Okay, that is k2x plus omega 2. See, I'll write here k2x plus omega t minus k1x plus omega 1t. So this minus this is equal to delta phi, and that is called as phase difference between the two waves y1 and y2. Clear? Written properly? Right, very good. And that is equal to delta phi. Like this you can differentiate between phase difference and phase. Okay na? ఇలా phi అని ఇస్తే ఒక్కోసారి అది లీడింగ్ అవ్వచ్చు, వేవ్ లాగింగ్ అవ్వచ్చు. ప్లస్ అంటే లీడింగ్, మైనస్ అంటే లాగింగ్. ఐ విల్ టెల్ some more points regarding this. Please try to note down. Please note down. See, just now I told you some equations. See here. Just now I told you some equations. Those are progressive wave enti y is equal to a sine kx minus omega t or omega t minus kx. Anywhere you can write. This is positive x direction. Okay. Now you can find out the velocity of this equation, because already in first year I told you simple harmonic motion low velocity and acceleration. Same way here also you can find the velocity of this body, particle, and also you can find out acceleration. Okay. If you find the first derivative, you will get velocity. Again, next, if you take one more derivative for that velocity, you will get acceleration. Now what I will do is, here, see here, we will try to find velocity. What is velocity? Dy by dt. So find the derivative with respect to time. So what is sin x derivative? Cos x. So cos, this entire term, theta, angle. So kx minus omega t into derivative with respect to constant kabatti 0 ayipotundi, and for this derivative again minus omega. So what is velocity? That is dy by dt, velocity of the particle. So it was just minus a omega cos kx minus omega t. This is velocity. Already I told you in SHM, simple harmonic. Now how to get acceleration again? So a is equal to again d by dt of v. Again finding derivative. That is minus a. What is sin cos x derivative? Minus sin x. So minus sin kx minus omega t. Again derivative of this one is minus omega. Therefore acceleration is equal to, you can show minus into minus plus, plus into again minus. So minus a omega square sin kx minus omega t. If you observe carefully in the above equation, a sin kx minus omega t is equal to y. Therefore, a is equal to minus y omega square. This is what? Nothing but SHM, particle making simple harmonic motion. So see here what happens. When it is SHM, a is proportional to what? Displacement from the main position, where omega is angular frequency, constant for a uniform motion. So this is how you can find the equations, just like in SHM. Clear? Please note down. Please note down. Clear? Now, sometimes what happens is, the equations will not be in the standard form. The equations will not be in the standard form. Then you have to change the equations. Chodda ela marchalo. Okay na? Right. Sometimes what happens is, for example, this is the displacement particle. A sin, okay, kx minus omega t, or y is equal to a sin omega t minus kx. Any of the form is right. ఇలా కాకుండా ఫర్ ఎగ్జాంపుల్ వాడు మీకు ఇలా ఇచ్చాడు అనుకోండి, y is equal to cos kx minus omega t, or y is equal to a cos omega t minus kx. Now both are in different forms. One is in sine function, another is in cos function. In such cases, what you have to do is change cos theta into sin theta by using trigonometry. I will write cos theta to convert into sin theta. Ela rayachu. So I can write in this fashion, theta minus pi by 2 or theta plus pi by 2. Can I write? Check చేయండి ఒకసారి. ట్రిగ్నామెట్రీలో ఇది ఫస్ట్ క్వాడ్రంట్, సెకండ్లో ఇక్కడ సైన్ థీటా కొసెకన్ థీటా పాజిటివ్, ఇక్కడ tan థీటా కాట్ థీటా పాజిటివ్, ఇక్కడ కాస్ థీటా సీకెన్ థీటా పాజిటివ్. వాట్ ఈస్ సైన్ 90 ప్లస్ థీటా? సెకండ్ క్వాడ్రంట్. సైన్ 90 ప్లస్ థీటా సెకండ్ క్వాడ్రంట్ అంటే సైన్ థీటాకి కాస్ థీటా రాయొచ్చు. బట్ సైన్ 90 ప్లస్ థీటా ఇన్ సెకండ్ క్వాడ్రంట్ ఏంటి? పాజిటివ్. So cos theta అంటే plus cos theta I can express in this form. Cos theta ఎలా రాయొచ్చు? theta plus pi by 2 లేదా theta plus 90 because sin 90 plus theta second quadrant cos theta and it is of course positive. ఒకవేళ మీకు మైనస్ ఇస్తే అప్పుడు ఎలా మారుస్తారు? How you will write minus cos theta? అప్పుడు మీరు ఏం చేస్తారు దీన్ని? sin theta minus pi by 2. చూడండి ఈ రెండు చాలా ఇంపార్టెంట్ ఫర్ కన్వర్టింగ్. cos theta ఇచ్చినప్పుడు టు కన్వర్ట్ ఇంటూ sin how will write sin theta plus pi by 2 because sin 90 plus theta second quadrant ఏంటి? cos theta and it is positive sin. ఓకేనా? అండ్ మైనస్ cos theta అప్పుడు ఎలా రాయొచ్చు? మైనస్ cos theta ఇచ్చినప్పుడు sin theta minus pi by 2 మీరు అడగవచ్చు సార్ ఇది ఎలా రైట్? చూడండి ఒకసారి. నా వాట్ ఐల్ డూ ఇస్ multiply and divide with minus 1 to make minus cos theta. This function I'll multiply and divide with minus 1. ఏమవుతుంది చూడండి. when you multiply and divide with minus 1 లోపల తీసుకెళ్ళిపోతే ఇక్కడ సైన్ ఏమవుతుంది? ఇది ప్లస్ ఇది మైనస్ అవుతుంది. అంటే sin 90 minus theta ఫస్ట్ క్వాడ్రంట్ cos theta. sin 90 minus theta ఫస్ట్ క్వాడ్రంట్ cos theta. సో ఆన్సర్ cos theta వచ్చింది, కింద మళ్ళీ మైనస్ ఉంది. సో మైనస్ cos theta. So like this you have to express. So if any function is given in terms of cos, then write it as sin theta plus pi by 2. If it is given as minus cos theta, write down as sin theta minus pi by 2 or 90 degrees. So please copy, these are very important. Now you can convert this one into this form. దీని ఈ ఫామ్లో మార్చవచ్చు. చూడండి ఒకసారి. ప్లీజ్ నోట్ డౌన్. Clear this one? Minus cos theta, theta minus pi by 2 and theta plus pi by 2. Now ఇప్పుడు ఇది ఎలా ఉంది? This is positive. So can I convert into sin now? So y is equal to a, this one, entire thing I can convert. How? Sin cos kada, theta plus theta and e value. This is entire thing is theta. Okay? Theta plus pi by 2. So I can write as y is equal to a sin theta. Theta plus ఎంత ఉంది? kx minus omega t plus pi by 2. Can I write in this fashion? Now I converted the equation a cos kx minus omega t just now I told you as cos theta. Cos theta how can write? See, cos theta I can write as sin theta plus pi by 2. Sin 90 plus theta second quadrant. Cos theta and of course positive there. So same way sin theta plus pi by 2, theta plus x kx. So now you observe the equations, first one and second one. First is a sin kx minus omega t and this one a sin kx minus omega t plus pi by 2. So this is the phase. Okay, this is the phase. And what is the difference between these two? Pi by 2. This is higher. This is leading by pi by 2 for this wave. If first wave is ఎంత leading లో ఉంది? Pi by 2 leading లో ఉంది. If you subtract also this will be gone. Pi by 2 is left over. Clear? So like this the phase difference and phase problems are solved. Clear? Right? Let us go still further. These are very important while solving numerical problems. Now, for example, let us go still further. Let us give a small relation between phase difference and path difference. Okay na? Phase difference ki path difference ki relation ichi, then we'll go still further. ఇంకొంచెం ముందుకు మనం వెళ్ళడానికి ట్రై చేద్దాం. ఓకేనా? we'll try to give a relation between phase difference and path difference. Relation between phase difference phi or delta phi and delta x, path difference. Phase difference means the angle between the two waves. Path difference means how much distance it is maintaining between the first wave or second wave. So we have relation delta phi is equal to k into delta x. Delta phi is equal to k into delta x, or delta phi is equal to what is k? 2 pi by lambda into delta x. This is very important formula. You have to note down for numericals. Chinna problem what cheddam. For example, take 5 is equal to, for example, say around pi by 3. For example, say phase difference phi is equal to pi by 3. Okay na? Now we have to convert this one into path reference. మీకు అర్థమవుతున్న క్వశ్చన్ అందాక ఒక చిన్న ఎగ్జాంపుల్ 5 ఈజ్ ఈక్వల్ టు పై బై 3 అనుకుందాం. వాట్ ఈస్ పై బై 3? 180 degrees. సో దీన్ని డెల్టా ఎక్స్లో మార్చాలి. ఎలా మార్చాలి చూడండి ఒకసారి. వాట్ ఈస్ డెల్టా 5? పై బై 3 ఈజ్ ఈక్వల్ టు 2 pi by lambda into delta x. Pi cancels. Okay na? Now what is left over? Cross multiply. చేస్తే lambda ఇక్కడికి వచ్చేస్తుంది. Lambda by 3 to just 6, that is equal to delta x. So if phase difference is value is pi by 3, path reference delta x ఎంత అవుతుంది? Lambda by 6, where lambda is the wavelength. You know how to calculate. So like this you can calculate any value if they are given in such conditions. Clear? So this is the relation between phase difference and path reference. Clear? Okay. Now let us go to another important thing, that is intensity of the sound wave. Okay na? This is also regularly they are asking in the examination. Intensity of the sound wave. Intensity of the sound wave. Intensity of the sound wave. See, generally intensity is given by 2 pi square f square a square rho into v. Intensity of sound wave is given by, normally intensity and enti anywhere, either intensity of light or intensity of sound, energy emitted per unit area and unit time. Energy, that means sound energy emitted per unit area in unit time. Here energy units ఏంటి? Standard SI unit joule per second, area meter square, and joule per second you know power, watts. So therefore watt per meter square. This is the SI unit of intensity. Okay. Now the equation, you have one equation for intensity of sound wave. 2 pi square constant f, frequency of the sound. Okay. A amplitude, rho density of the medium, and v is the velocity of the wave. Okay. And finally all these are constant, therefore intensity you can write as directly proportional to amplitude square. Intensity is given by directly proportional to amplitude square. General equation 2 pi square f square a square into rho v. Rho is the density of the medium, v is the velocity of the sound wave. Okay. A is amplitude, f is frequency. Frequency you can even take n also. 2 pi square is again constant. This is the general equation between intensity and amplitude. Very important equation, that one. Please make a note. 2 pi square f square a square into rho v. Okay. Right. Now after learning about the intensity, we have one more term we have to learn now, that is wave velocity equation. That is velocity of the transverse wave of a stretched string. Velocity of a transverse wave of a stretched string. So generally it is given by v is equal to root over t by m. In some books m is also taken as mu. కొన్ని పుస్తకాలు ఈ m ని mu అని రాస్తున్నారు. That is called a linear density of the string. Linear density, it is given a mass per unit length, that is units, kg per meter SI units. So నేను మాత్రం I want to use mu, I will use m only. Here m is not mass, linear density. So ఇప్పుడు ఏమవుతుంది equation V is equal to root over T by what is linear density? Mass per unit length. Mass value if you divide with length, then this is a perfect equation for velocity of the wave of a stretched string. Okay, so from this also you can do some numericals in the examination and units meters per second. Velocity covered. Clear? Any doubts up to this juncture? Right. Now let us go to the next one. What are the formulas for intensity of sound wave for point source and also for linear source? Intensity of sound wave for point source and linear source. So point source and తెలుసు కదా. Okay, this is how it is going. Intensity is going outside, and for example at some distance d if you take, how it is given? I is inversely proportional to d square. I is inverse, intensity is proportional to d square or r square. For a point source, it is taken as intensity is inversely proportional to distance. More distance, less intensity. Less distance, more intensity. In the same way for linear source. Okay? In the same way for linear source, the intensity is given inversely proportional to distance. Inversely proportional to distance. In linear source, it is inversely proportional to distance. Whatever distance the point is taken. Okay? For point source, the intensity is given as inversely proportional to square of the distance. Okay? So these are the things we'll be using in the numericals. Please make a note. Very important. Clear? Right. See, as I told you, the sound chapter is a very big chapter. So I'll also try to divide this chapter into part 1 and part 2. We'll see. Anyhow, this one you can take it as part 1 sound waves. We'll see how much we'll complete today. And later on remaining part we will complete in the second part. Now let us go and try to understand relation between intensity of the wave, sound wave, and amplitudes. Okay, by using principle of superposition. By using superposition principle. You know the superposition principle, y is equal to y net is equal to y1 plus y2. Okay, that is sum of the two waves, y is equal to y net is equal to y1 plus y2. For example, you are given with two waves, say for example ఒక wave మీకు y1 is equal to a1 sine. For example, you are given with two waves, y1 is equal to a1 sine omega t1 plus kx1. Okay, అలాగే a2 sine omega t2 kx2. Okay na? These are two waves you are given, for example. One wave, two wave. First wave ఏంటి a1 sine omega t1 plus kx1. Second wave a2 sine omega 2 plus kx2. So how will get y net? Y net is nothing but y1 plus y2. The sum of the two waves is nothing but the resultant. Okay na? Now ఈ రెండింటి యొక్క రిజల్టెంట్ మనం సింపుల్ మెథడ్లో మీకు చెప్తాను, by using parallelogram law. To get the resultant of these two, I will use parallelogram law. అదేంటంటే ఫర్ ఎగ్జాంపుల్ ఈ రెండింటి మధ్యన సపోజ్ ద డిఫరెన్స్ బిట్వీన్ ద టూ వేవ్స్ ఈజ్ సే 5. అంటే ఫర్ ఎగ్జాంపుల్ ఐ విల్ టేక్ ద ఫస్ట్ వేవ్ ఈజ్ లాగింగ్ and second wave is leading, for example. Udahanaki is here. This is the first wave with amplitude A1. Second wave A2. So the phase difference between them is say phi. It is leading. Okay, first wave is A1, second wave is A2. The phase difference between them is say phi. Okay, now how to get the resultant by using principle of superposition? Y1 plus Y2. But I will use parallelogram law to get resultant. To get resultant, A resultant, amplitude resultant, I will use simple formula by using parallelogram law. Hello, sir, chudandi. A resultant whole square, that is, what is parallelogram law? A bar square plus B bar square plus 2A bar B bar cos theta. So, ikkada kuda ante AR square is equal to A1 square, A2 square plus 2A1 A2 cos phi. Clear? So, what is the resultant of these two? I am thinking the first one is A1 is lesser one, second one is higher one. So, the phase difference between them phi anukunte, I can use the formula parallelogram law and get the resultant. So, what is A resultant square? Yes, A1 square plus A2 square plus 2A1 A2 cos phi. But we know what is I just now 5 minutes back I told you. Directly proportional to A square, or I resultant is proportional to A resultant square, or I1 proportional to A1 square, or I2 proportional to A2 square. Because intensity I given a formula 2 pi square f square A square rho v. So intensity of sound is directly proportional to amplitude. Put all these here. What is AR? AR square. I can write as IR. Because it is proportional. Proportional to this constant betana, constant motto cancel అయిపోతుంది. Throughout constant is cancelled. So that is why I am taking out constant outside. So instead of AR I can write IR. Instead of A1 square I can write I1. A2, I2 plus 2 in the place of A1 root I1. In the place of A2 root I2 cos phi. Can you observe this equation? This is in the form of resultant intensity of the two waves. And this is the resultant amplitude of the two waves. Now when this wave is maximum, so when phi is equal to 0 degrees, cos phi, that is cos 0 is equal to 1 for maximum. అప్పుడు ఏమవుతుంది ఇది? ఈ వాల్యూ ఏమవుతుంది చూడండి ఒకసారి. AR square is equal to A1 square plus A2 square plus 2A1 A2 cos phi maximum 1 పెట్టారు. 0 అని అయిందండి యాంగిల్. రెండు మీద యాంగిల్ 0 అయితే cos 0 1 కాబట్టి 1. అప్పుడు ఇది ఏమైంది? A plus B whole square అంటే ఏమవుతుంది ఇది? AR whole square is equal to A1 plus A2 whole square I can write A square plus B square plus 2AB. And this is nothing but what? A1 plus A2. What is the resultant I got? Resultant amplitude A1 plus A2. Please note down. Very, very important. Very, very important this one. Principle of superposition. So I got the value as how much? Amplitude value ఎంత వచ్చింది నాకు? A resultant ఎంత? A resultant I got it as A1 plus A2. And what is I resultant I got? I resultant ఎంత వచ్చింది? Resultant intensity I1 plus I2 plus 2. ఇక్కడ కూడా for example if you put what? Maximum అంటే cos 0 1. అప్పుడు ఎంత అవుతుంది ఇది? Root I1 plus root I2 whole square రాసుకోవచ్చు కదా? అప్పుడు ఏమవుతుంది? A square plus B square plus 2AB. సో ఈ ఫార్ములా రాసుకోవచ్చు మీరు. అదవుతుందా? దిస్ ఈజ్ ద రిజల్టెంట్ వాల్యూ ఫర్ మ్యాక్సిమం, దట్ ఈస్ A రిజల్టెంట్ యాంప్లిట్యూడ్ ఈజ్ ఈక్వల్ A1 plus A2. అండ్ ఇన్ ద ఫార్మ్ ఆఫ్ ఇంటెన్సిటీ ఏంటి? I రిజల్టెంట్ రూట్ I1 plus రూట్ I2 హోల్ స్క్వేర్. చూసుకోండి ఒకసారి. ఐఆర్ ఎంత వచ్చింది? I1 plus I2 plus 2 root I1 I2. ఒకవేళ ఇది కాస్ మ్యాక్సిమం అయితే ఎంత అవుతుంది? cos 0 degrees. cos 0 is equal to 1. అప్పుడు ఇది ఎంత అవుతుంది? రూట్ I1 ప్లస్ రూట్ I2 హోల్ స్క్వేర్. బట్ యాక్చువల్లీ స్ట్రిక్ట్లీ స్పీకింగ్ వాట్ ఈజ్ రూట్ I1? రూట్ I1 ఎంత అండి? వాట్ ఈజ్ రూట్ I1? A1. And what is root I2? A2. If you put it here, what happens? I resultant for maximum is equal to root I1 is equal to A1. Root I1 is equal to A1 plus root I2 and the A2 whole square. So this is the equation expression for maximum intensity, and this is for maximum amplitude. A1 plus A2 whole square maximum intensity, and A1 plus A2 maximum amplitude. In the same fashion you can find out for minimum. So in the same way you can find for minimum. I'll write it here for minimum. When cos is minimum, can you tell me? Cos minimum ఎప్పుడు అవుతుంది? When it is 90. కాదు. What is cos phi? 180 minus 1. So 0 కన్నా తక్కువ -1 కదా. So cos is minimum at 90 and also -1. But -1 is still lesser than 0. So cos 180. For example, if you put 180 here, see here, this function, write in the equation, see, I'll write here, AR square is equal to A1 square plus A2 square plus 2A1 A2 cos phi place of, suppose if you put pi for minimum A and I. So cos pi -1, ఇక్కడికి వచ్చేస్తుంది -1. అప్పుడు ఎంత అవుతుంది? AR square is equal to A1 square plus A2 square minus 2A1 A2. ఓకేనా? cos పై మైనస్ వచ్చేస్తుంది కదా, ఇంకా కాస్ ఉండదు, ఇంకా minus 2A1 A2. ఇది ఎలా ఉంది ఒకసారి చూడండి. A minus B whole square. సో AR whole square ఇది ఎలా రాయించింది? A minus B whole square. A square plus B square minus 2AB. And this is nothing but what again? A resultant is equal to root over, root cancel అయిపోతుంది square, A1 minus A2. So what is the value here? Maximum అయితే ఇది amplitude for maximum. Minimum అయితే ఏమైంది? A1 minus A2 cancel అయిపోతుంది square. This is for minimum. When it is pi, cos is pi. So for maximum resultant amplitude A1 plus A2, and for minimum A1 minus A2. In the same intensity కూడా మార్చుకోవచ్చు. What is the intensity formula? IR is equal to I1 plus I2. ఇక్కడ పై పెడితే మైనస్ కాబట్టి ఇక్కడ మైనస్ వచ్చేస్తుంది. -2 root I1 root I2. Again same, A minus B whole square. So IR is nothing but root I1 minus root I2 whole square. So A square plus B square minus 2AB. But strictly speaking, what is IR? Resultant for minimum. Resultant intensity for minimum. And what is root I1? Root I1, A1. Root I1 and enda A1. And what is root I2? A2. So A1 minus A2 paina undi whole square. Clear? For maximum value of amplitude, it is A1 plus A2. For intensity, you can see A1 plus A2 whole square. And for minimum, amplitude is A1 minus A2. And for intensity, it is minimum A1 minus A2 whole square. So these are very, 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 very important things you have to learn. And in the examination also, regularly they are asking, please. So please make a note. In sound waves chapter, concept is also there and also numericals. Both you have to study well. Otherwise, you cannot solve the problems. As I said just now, many things have discussed in the last half an hour or so. Many things starting from sound, definition, equations, etc. Okay? Now what I'll do is, in the next, because I just now I told you it's a very big chapter, lengthy chapter, I'll divide this chapter into 2 parts. Now these sound waves, I'll take it as first part. So we have completed up to resultant waves and intensity of the sound waves. Next part, in part 2 of sound waves, in the second year, we'll be dealing the remaining part, that is constructive sound waves and destructive sound waves. Constructive, ఇవి మళ్ళీ సేమ్ థింగ్ అగైన్ విల్ బి స్టడింగ్ ఇన్ లైట్ అగైన్, దట్ ఈస్ ఫిజికల్ ఆప్టిక్స్. అందుకే ఇక్కడ మీరు బాగా నేర్చుకుంటే సౌండ్ చాప్టర్లో ఈ కన్స్ట్రక్టివ్ సూపర్పోజిషన్ వేవ్స్ హౌ దే ఆర్ ఫార్మ్ అండ్ డిస్ట్రక్టివ్ సూపర్పోజిషన్ సౌండ్ వేవ్స్ హౌ దే ఆర్ ఫార్మ్ with equations and other things I'll derive for you in the next part of the sound chapter. Okay, so next part, the remaining chapter will be completed. Okay, right.